You've probably heard of the science of reading. It's transformed reading instruction by creating a structure for how we can effectively teach literacy using research and evidence-based practices. But what does the research say about effective math instruction? Welcome to the science of math. Today, we're diving into the research on how neuroscience, psychology, and evidence-based practices can revolutionize math education, helping students develop number sense, problem-solving strategies, and math fact fluency. If we can change how we can teach math, then we can change how students experience it. Welcome, I'm Becky, your go-to guide on how we can align math instruction with neuroscience so that everyone can learn and love math. If that's what you'd like to learn more about, then hit subscribe because we're going to be sharing a lot more content to make our math teaching mathemagical. If you'd like to go deeper, check out our free resources at lordmath.com, as well as our online course, Decoding Math, and our new structured numeracy curriculum called Mathemagical. Ready to create math-confident kids? Let's get into it. You may have heard of the science of reading. Now let's talk the science of math. I like to start these discussions with what we know about literacy, then parallel it to math for two reasons. First, literacy is much farther ahead than math in terms of research and development of what effective instruction is. Second, most people are much more familiar and comfortable with reading than they are with math. So for both these reasons, starting with literacy gives us a helpful foundation for understanding what effective math instruction might be. So what is the science of reading? A web search on the science of reading describes it as a body of research spanning multiple disciplines that investigates how children learn to read and provides evidence-based guidance for effective reading instruction, focusing on foundational skills like phonemic awareness and phonics. Deeper exploration to the science of math makes the case that we need to pull not just from education research, which generally focuses on pedagogy and materials, but also neuroscience, psychology, and linguistics. I would say the same goes for math. In March of 2020, when COVID hit and the world came to a sudden and unexpected standstill, I was deep into completing a review of math research for a graduate class I was taking on math interventions. I spent those first 2 weeks of shutdown pouring through research, summarizing the themes, and writing a review. If you're curious what I found, you can find my review linked in this blog. I went into this research review thinking that the way research works is that someone out there does extensive research on a topic like teaching math, discovers what methods work best, then develops those discoveries into instructional methods. And that's how we found effective instruction. What I realized is that it's quite the opposite. Research on a particular instructional method doesn't exist until someone decides to do a study on it. So the methods exist first. Then research studies are done, indicating how effective they are compared to a control group. In fields like math instruction, where there is relatively little research compared to reading, it may mean that there are many instructional approaches that just don't have any existing research on them to let us know whether they are effective or not. So while we want to utilize existing research demonstrating methods that are effective and those that are not, we also should not automatically exclude methods that do not yet have research. Here's the thing, nothing has research until it does, until someone decides to do a high-quality study on it, demonstrating its efficacy or lack thereof. Then we can make more informed choices about that method. So what does the research say about effective math instruction? To begin, it's helpful to recognize that there are several websites that summarize existing math interventions and research-based approaches. In taking the guesswork out of locating evidence-based practices for diverse learners, Hughes provided several options for locating evidence-based practices. What Works Clearinghouse, Best Evidence Encyclopedia, the National Center on Intensive Intervention, Evidence-Based Intervention Network, and the IRIS Center. All the resources I'm mentioning today are linked in this blog. A variety of resources summarize and address the most salient features of existing research. High leverage practices for students with disabilities by the Council for Exceptional Children. Forward Together, a school leader's guide to creating inclusive schools by the National Center for Learning Disabilities and Understood.org. And the Practice Guide, Assisting Students Struggling with Mathematics, Response to Intervention for Elementary and Middle School by the Institute of Educational Sciences. In the field of research on math instruction, there are two practices that have the most research. First, explicit systematic instruction. Second, word problem instruction, specifically using two methods. First, attack strategies based on cognitive strategy instruction. Attack strategies consist of a series of steps or a plan of attack to follow when solving word problems. Second, schema-based instruction, particularly with an emphasis on transfer to novel situations. Schema-based instruction is a method that helps students solve word problems by teaching them that there are word problem types and to identify the underlying structure or schema of each type. Forward Together identified 4 practices for evidence-based math instruction. First, explicit instruction with cumulative practice. Second, the use of visual representations. Third, schema-based instruction. Fourth, peer interaction. There are other practices that have strong research demonstrating their effectiveness. Math fact fluency, practice and instruction, screening students for potential math difficulties, and providing interventions. Currently, the science of math conversations focus mostly on those practices that have existing research. Explicit instruction, attack strategies, and schema-based instruction for word problems, the use of visual representations, and fluency practice. The missing piece. What I couldn't help but notice was missing from educational research was anything about subitizing. Yet, there is a significant body of research within neuroscience and developmental psychology about the existence of our innate subitizing abilities. Here is a snapshot of some existing research on subitizing and groupitizing. Subitizing, what is it? Why teach it? Subitizing is sensitive to the arrangement of objects. Effects of daily practice on subitizing, visual counting, and basic arithmetic skills. Groupitizing reflects conceptual developments in math cognition and inequities in math achievement from childhood through adolescence. In addition to this body of research, I also knew from my extensive work in the field of dyscalculia that developing subitizing and groupitizing using dot patterns is the foundation and effective remediation for developing number sense and math fact knowledge, particularly in students with dyscalculia and math learning difficulties. Expanding the conversation. I parallel developing our subitizing and groupitizing abilities in order to develop number sense and learn math facts to developing phonemic awareness and phonics in order to learn to read. Imagine discussing the science of reading and structured literacy, but saying nothing about phonemic awareness or phonics. What would we be left with? Explicit systematic instruction, but in what? I believe that our science of math conversations should pull from what we know from research to be effective and not effective, while also exploring methods that are currently being used very successfully for students with dyscalculia. We need to open up our discussions to include the emerging fields of neuroscience, psychology, and number sense, and focus not just on the past methods that we already have research on, but also what do we need to get new research on. Let's expand our vision to create a model for effective math instruction that doesn't just address the how, explicit systematic instruction, but also the what. What should that explicit instruction be on in order for students to develop strong number sense? And then the when. When is it developmentally appropriate to teach each component? How do we actually provide and implement the instruction? Just as the science of reading has led to structured literacy, a model for effectively teaching literacy based on research and evidence-based practices, the science of math needs to lead towards structured numeracy, a model for effectively teaching numeracy based on research and evidence-based practices. So what do I recommend? Well, here's the science of math in a nutshell. Provide explicit, systematic instruction using the best manipulatives and visual representations in subitizing and groupitizing to develop number sense and math facts, schema-based instruction and attack strategies to develop problem solving and conceptual understanding of the operations and their relationships. Then provide frequent interleaved opportunities for practice over time to develop fluency. Thank you so much for being here. If you're as excited as I am about transforming math education to be as effective as possible, hit subscribe below and check out our other resources at lordmath.com. I've got so much more Mathemagical content coming your way. While you're at it, please share this video with anyone you know who will find it helpful. Let's work together to make math learning better for all. See you soon.